Hello guys, how are you? So on today's video our task is to determine greatest common divisor and lowest common multiple using Euclid algorithm. So first of all, to start, you need to know what is greatest common divisor and lowest common multiple. So greatest common divisor says, just like take an example, there were two numbers. First one is an 8 and is 12. So he says the greatest common numbers that divides both the number is the greatest common divisor of both the number. Just like he said, it will be calculated by using a prime factorization method. Just like for 8, it will be a 2 square, 2 square plus 4 plus the 4 square. Okay, the 4 into 2. And for the 12, it will becomes 2 square 4 plus into multiplies by into 3 to power 0. So the GCD of both the numbers will what the GCD greatest common divisor of both the number which divides both the number. So in this case the greatest common divisor of both the number is 4. You can see the common divisors in both the number is 12, and the LCM, the lowest common multiple in both the number be will becomes lowest common multiple what will the least common multiple of both the number would be 24 in this time, 4 from 8, and the counted goes from on to the 12 and 3 from this side becomes 4. The common pair it will use 4 and it will use 3, so put after multiplying 2 common pair that's 2 and 3, so it becomes 24 LCM. So in this time greatest common divisor and LCM will found out, and there is a tree. If you watch, just like 8 and 12 number is given, if we somehow multiply their factorization just like as the given, the 8 factorization should be comes as let's the factorization of 8 will become as 2 into 2 square into 3 to power 0, and the prime factorization of 12 will be stated as 2 square into 3 to the power 1. Okay, if you reading the both the prime factorization of both the number and greatest divided by their LCM by 24. It's like if we divide by the LCM, which is 24. So what you watch? The 4 is divide that number and use 6 times. Divide that number in 6 times, and 3 will divide that number into 2 times, and 2 will divide that numbers into 2 times. So the result will comes at 2. Here will comes at 4. So you watch when we calculating the factorization and calculating and adding the factorization of both the number and dividing by their LCM, then the number comes will be a greatest common divisor. So this is a very important formula to should write it. This is constantly used that GCD of any number divided by Prime factorization, multiples of any number, just like any two numbers, multiples of any two number divided by greatest common divisor will give the LCM of that number. So you can also say the multiples of two numbers divided by LCM will give the greatest common divisor. So till then the greatest common divisor will be stated, calculated, and we need to move on to our next step. So our target is to calculate it using a Euclid algorithm. So Euclid, by calculating using Euclid algorithm says, let's suppose our question is to calculate the greatest common divisor by of two number which is 18 and 12. So I say I am just going to divide the number with our division is 12 and dividend is 18, and I just divide that number. So when I divide, the remainder comes 6. So I says when the remainder after dividing the divisor, please make my divisor to a dividend and remainder to a new divisor. So as you see, then 12 comes here and we divide it again. Okay, so you can see when we divide by 2 times, then the remainder comes. So for solving using Euclid algorithm, I says when the remainder comes, divide it again. When a divisor comes, when the I says when the remainder comes, then returns the divisor, because this is your GCD. This is a Euclid algorithm. It says divide the number, divide a particular number, divide a particular number at the number of times till it reaches the remainder. Then the divisor that gives the remainder 0 is the greatest common divisor of that number. So in this case, the greatest common divisor of the number is 6. So our first case is while dividing the number, if remainder comes, then divisor becomes dividend, divisor becomes dividend, and remainder becomes divisor, and remainder becomes divisor. So it divides it completely in the 12. So when remainder comes, I also say when reminders comes 0, then please return my divisor, because this is a greatest common divisor. So our approach is pretty simple. You can also try. So come on to our fourth part. I say okay, I say I have an GCD function. And GCD function is the parameter for divisor and dividend. In a divisor, I say keep divide the number divisor. So our new dividend became divisor. Our new divisor becomes dividend, and new remainder becomes divisor. So our new dividend becomes divisor, new divisor became dividend, and remainder becomes divisor. So what will be the remainder? Remainder is it is nothing but a modulo b. Okay, is the remainder of a is a number and is nothing but a modulo b, because this will use the remainder after dividing the divisor. So this is the situation a modulo b. After return the greatest common divisor of till now our function will works correctly. So in this time our function will works correctly, but there is a missing. One thing is missed. Just say what is the one thing that is missing? Is our base condition. When our remainder becomes zero, then we need to return something. So the return thing is the the divisor. So I can say if when our remainder becomes zero, then return our divisor. Okay. So you can see the code will be very less. Okay, the code will be very sorted, and for printing the result it should be in the main function, and for converting into main what we gonna do? I said just print my greatest common divisor of both the number. What will the greatest common divisor? The number is 10 and 20 as it given. Just like if we want to see the result of greatest common divisor of both the number, so you can see the answer will shown by a 10. The compiler says when you do the greatest common divisor it will be 10. You can also check by it is right. So you can also want, if you want to see the least common multiple of that number, so you can also see by doing greatest common divisor by multiplying a into b divided by the greatest common divisor of that number, which is 10 and 20. Okay. Just like if you want to see, you can also get. You can also see change the base condition. It will say when remainder is becomes zero, then return the divisor. You can also say when remainder becomes zero, then keep continuing. Then keep continuing. The divisor again becomes the dividend at this time, and it again when it divides the number with that number, then the result will then remainder becomes then the remainder becomes dividend. So we can also say at the last condition when dividend becomes remainder, just give me the dividend, because dividend at the time the dividend is our divisor, and then dividend is the greatest common integer. So we can also change the base condition. So it will be a when our remainder becomes zero. Okay. When our dividend, so in this time what is a dividend? A is a dividend. Now a dividend becomes remainder. So for second base condition, I can say when our new divisor becomes zero, then return the previous divisor. So now new divisor becomes zero, then return the previous divisor, which is a. Okay. you can also state it as in this way. If you talk about time complexity, the algorithms it is still calling the function again and again is big of n times, and so the time complexity will be big of n, and we are not using any extra spaces, so it will remain as it is. So that's for today, guys. You can calculate greatest common divisor and lowest and least common multiple easily. So for more videos, just subscribe with our channel.